What exactly are enzymes and how are they involved in tea processing? Well, enzymes are proteins that catalyze chemical reactions. On a molecular level, they cut things, they glue things, or they cut and paste things. So what are proteins then? Proteins are structural molecules that are in your hair, your skin, and your muscle. They're in every plant, animal, and human cell. They're essential to life, and they're made up of amino acid subunits. So let's draw a couple of amino acids and see what those things are. Okay, that's one amino acid, and I'm going to draw another one here and show how they're bonded together to make a protein. Just like starches are made up of sugar subunits, proteins are made up of amino acid subunits. And why are they called amino acids? Well, here's the amino group, it's a little bit of a base. Here's the acid group, and of course that's acidic. So how do you bind these two together? Well, strangely, you need an enzyme, which brings us to that chicken and egg conundrum. Anyway, so the enzyme comes in here, gets rid of this H and this OH, kicks off a water molecule, and makes this into a dipeptide. You do it again and again and again, and you link hundreds and thousands of them together, and now you've got a protein. And over the centuries, crafty tea farmers have figured out that you can harness the power of enzymes to make the 6 different types of tea and express the different characteristics of each tea. So let's say you're a green tea farmer. Well, you're going to apply heat early on because you don't want those enzymes doing too much stuff. So the heat is going to cook the enzymes, called irreversibly denaturing them, and that's going to change the shape and in their function. It's going to kill them. In Chinese, it's called shaqing, which translates directly to kill the green. Sounds kind of funny in English. But if you're a oolong tea farmer, you're going to want to do the exact opposite. You're going to want to induce those enzymes so you can make a lot more molecules. Molecules that are characteristic of oolong teas. And how do you do that? Well, you trick the tea leaf into doing it by stressing the tea leaf. And in this case, it's by turning the leaves over, letting them rest, turning them over, and then bouncing them and letting them rest. And the tea leaf says, wow, what's going on here? I got some sort of an external stress. So it mounts a chemical defense. Let's take a look at some of those molecules that it makes. But first, let's take a look at an interesting 3D representation of what happens with enzymes. So this is an enzyme, and I chose a snake because it's got a mouth and it's going to bite things and cut things. If you're a green tea farmer, it's going to cut a little bit and do a little bit. Then you're going to add heat, you're going to change the shape, and you're going to kill it or irreversibly denature it. But if you're an oolong tea farmer, you're going to want to enhance this enzyme. You're going to want it to make hundreds and thousands of molecules. So this one and then these other ones, they're going to start going over here and cutting and pasting and making all kinds of crazy molecules. And then when you think it's just perfect, you are also going to do the same thing that the green tea farmer did. You're going to apply heat. You're going to irreversibly denature these enzymes, change their shape, because their job is done. So now let's take a look at some molecules that are inside of oolong teas that are the result of those enzymes. Okay, this one is called linalool. Linalool is a really floral molecule that has notes of citrus peel and wildflowers. It smells just great. This next one is jasmine lactone. It is fruity, and of course, the name gives it away that it has jasmine-like qualities as well. Now you'll notice that this is a carbon here, and then whatever's not drawn in are hydrogens. So these are carbons and hydrogens, and that's what a terpene is. But because these have oxygen, they're called terpenoids. That same kind of class of family. And they are made from the enzymatic breakdown of lipids that are naturally occurring inside the cells of tea leaves. So these are something like fatty acids or phospholipids that make up the cell membrane. Anyway, lots and lots of very complex chemical reactions, lots and lots of enzymes that go into making these molecules. And these are actually used as a defense for the tea tree, the tea leaves, into mounting that defense. And to humans, though, they smell quite pleasant. So they're really bad for bugs, but they're really good for humans. And in fact, both of these two molecules are in my absolute favorite tea of all time, which is Phoenix Mountain Honeysuckle Fragrance Oolong Tea. I drink that tea every day and I just love it. So next time you're drinking your favorite tea, sit back and contemplate a little bit and give thanks to the tea tree, the tea farmer, and the enzymes for making all of this possible.